Hello students, very warm welcome in this beautiful session of Super 20 series for GATE 2026. So before I start, I would like to ask you whether I am audible and visible. Audio, video, everything is clear. Audio, video, everything is clear. Right. So are you ready, guys? So are you ready with pen, paper and calculator? Because in this session we are going to solve some of very important questions, some of very good questions as far as thermodynamic subject is concerned. Kaise ho? I am very much good, right? I am very good, all clear, very good. Very good. So very good afternoon and very warm welcome in this beautiful session, right? Beautiful subject of basic thermodynamics in this very beautiful series, that is Super 20 series for GATE 2026. One more thing I would like to clear here, that whatever question we are going to solve here, that is just aligned to the GATE exam, right? The way GATE is asking the question, the way IIT asks the question, similar kind of question I am going to put it here, right? I am not going to make such a very hard question so that you will say, oh sir, you are very great because your questions are very great, you are solving such a tough problems. No, I am not here, please listen here carefully, I am not here to show that I can solve such a great problem or such a difficult problem. But the main task of this particular session, that you need to understand that what kind of questions may ask in upcoming GATE exams, right? Suppose unnecessarily if I start solving the problem, very difficult problem, and you will say and the last moment, right, it is hardly 20-25 days are remaining, now you will realize, oh my god, I'm not able to solve the problem, then your confidence level will go, right? So here step by step, right, all the type of questions are there. 1 marks questions are also there, which are little bit easy, one step problems, correct? Then some 2 marks questions are there, which are little bit difficult, I would say, not difficult, I would say little bit lengthy, or would say 2-step problems basically, right? So okay, so let's start. So basically in this Super 20 series, if you have seen, already 2 subjects are completed, right? One, strength of material, already completed at 4th January. Then manufacturing process 1, that is also completed. Now today we are going to solve the problems related to basics of thermodynamics. Basic of thermodynamics. Then after that, manufacturing process 2 will be there at 10th January. Then applied thermodynamics will be there. Then again I will come, right? Again I will come and take 14th January. 14th January will again start with the fluid mechanics, right? So fluid mechanics Super 20 question also we will solve. So I think, yes, you are from chemical. Very good, very good, very good. So here these problems, right, whatever problems we are going to solve, these problems are not only useful for mechanical, it is useful for chemical, it is useful for aerospace, it is useful for other branches where this production and all, XC production and all. Okay, so shall we start? Shall we start, my dear student friends? If you say yes, then just make a heart for your teacher. Just make a heart, then we'll start. We'll start with a good heart. Sir, I like your motivation videos. Oh, thank you very much. There will be less comedy. Yeah, this is true. Because it is a question practice session, so obviously there will be no comedy at all. By the way, I'm not here to do the comedy. See, sometimes people are confused. I am teaching thermodynamics. In thermodynamics, little bit comedy is also there, little bit motivation is also there, all the. But don't say reverse. Some people say, sir, comedy is not there today. Arey bhai, we are going to study the thermodynamics. In thermodynamics, comedy will be there. In comedy, thermodynamics is not there. People are thinking, sir, you are comedian, I think, and little bit you are teaching thermodynamics also. It is not like that, okay? Day before studied thermodynamics revision over, so based on that, we can get question right. Yes, 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 yes. Yes, definitely. Sir, what about EC Valley, madam? EC Valley, madam, is very, very beautiful. Okay, solve fast. Okay, just solve the problem. Solve the problem. Yes. So here it is given that it's a very simple 1 marks question, right? Can be solved by two different methods. Here it is given that a gas expand with the, like, given that the relation between pressure and volume is given. So P is equal to minus 250 V plus 600. This is the pressure and volume relation is given. Volume is in meter cube, pressure is in kilopascal. What is the work done if it expands from 0.1 meter cube to 0.4 meter cube? 0.1 meter cube to 0.4. Actually, two methods are there to solve, right? One with the help of formula. Right? So what is the formula to get the work, right? To get the work actually, so W is equal to integration 1 to 2 PdV. Yesterday we discussed, right? This is a closed system displacement work. Now in this one we can write like 1 to 2 minus 250 V plus 600 into dV. Now if I integrate this one, you will get minus 250 V2 square minus V1 square by 2. Correct? V2 square minus V1 square by 2 plus 600 into V2 minus V1. Very simple. Simply you just have to integrate and put the value, you will get the answer, right? You will get the answer very easily. So here I can write like 250 divided by 2. So how much it will come? So 250 divided by 2, how much it will come? 125. So minus 125 V2 square. What is the final volume? Final volume is 0.4. So 0.4 ka square minus 0.1 ka square. Correct? Plus 600 into 0.4 minus 0.1. So this value will come how much? 0.4 ka square minus 0.1 ka square. So you will get a 0.15 basically, right? 0.15 into 125. So this value you are going to get minus 18.75 and plus this value you will get a 600 into 0.3, right? So you will get 180, right? 180. So 180 minus 18.75. So you will get a 161.25 kilojoule. So B is going to be correct answer. There is one more method actually. This is the actually better way, right? This is the better way. Sir, रात को class करेंगे क्या? हाँ, today. अच्छा, one more thing I would like to share here. That today again one abhyas session is there, whether you remember or not. Today one more abhyasi. Here I am going to discuss only 20 problems. In this session I am going to discuss only 20 problems based on basic thermodynamics. Today 7 p.m. onwards. I will discuss even more than 35 problems we are going to discuss in Abhyas session, Mahabhyas. That will be in different channel, mechanical channel. That is mechanical channel. So I will suggest you everyone that please solve these questions by your own. And stay in touch with me in Telegram. I will share the link. and today evening 7 o'clock onwards Maha Abhyas session will be there. Okay, so I will share my Telegram channel also. If you are not connected with me, then you can connect with me. My name is Shivam Dixit. So Shivam Dixit sir PW. You can search this one, or if you are not able, this Telegram channel basically. If you are not able to find from this, then you can use here Shivam sir physics Wallah. Shivam sir physics Wallah, right? So one more method is there. Right, one more method is there to solve this problem. I'm not going to use I'm not going to solve that problem, correct? I'm not going to solve that problem with that method, but I will give you how you can solve. So first you can calculate P1 value. First you calculate P1 value with the help of this particular equation, then find out the P2 value with the help of the same equation. Then it is a linear variation, so draw P1 V1, P2 V2 and match this with a straight line, match this with a straight line, match this with a straight line, and then area under the curve, right? If you say I can solve this, right, see from here actually you will get P1 value, you will get how much? P1 value you will get minus 250 V1 value is how much? 0.1. So into 0.1 plus 600, right? So 0.1 means minus 25. So 600 minus 25 means 575 kilopascal. This is P1 value. Similarly, you can calculate P2 value also. So minus 250 into 0.4 plus 600. So minus 250 into 0.4. So this value will come 500 kilopascal. Now, if I draw here the P1 V1 and P2 V2, right? If I draw here the P1 V1 and P2 V2, so P1 values 575 and V1 value is 0.1. So this is basically 1 point. Here it is 575 kilopascal. This value is 0.1. This value is 0.1. Another point is somewhere here where pressure is reduced to 500 kilopascal and volume is become 0.4, right? The pressure and volume relation is given. Like in a straight line. It is given as a straight line because P is equal to A plus, like you can say Y is equal to mx plus C kind of equation, correct? So this is basically a straight line variation. Pressure and volume relation is linear. Now the work is given by the area under the curve, right? So this area, right? So W1 to 2 can be written as area under line, right? Under line. So this value will come half. Sum of parallel lines means 575 plus 500, right, into this distance means 0.4 minus 0.1. This is another method, right? So from here you will get 575 plus 500 divided by 2 into 0.3, right? So you will get 161.25 kilojoule. Clear? Please listen here. You can solve the problem. Yesterday also I clearly mentioned that. Whether you can solve the problem with the help of formula or you can solve the problem with the help of area under the curve, you will get the same answer. Okay. Okay, let's solve the next problem. Sir, not maja in English. Are maja, Akshay, maja is there in English also. If I tell you the story, then you will feel maja. Sir, directly रात को क्लास करूंगा. बहुत मारेंगे तुमको, हम बता रहे. कोई नहीं जाएगा यहाँ पे. Everyone is going to stay here because these question I am not going to repeat in रात. रात का मजा रात को लेंगे, दिन का मजा दिन को लो। समझ में आ रहा है, राइट? ये दिन के क्वेश्चन अलग है, रात के क्वेश्चन अलग है। Why you people are behaving like this? So evening question will solve in evening. These are afternoon questions. So these questions are not going to repeat. Sir, FLT. Yes, first law of thermodynamics. सर FLT के बारे में कुछ बताइए, पूछिए पूछिए सौम्या बिटिया, सौम्या बिटिया पूछिए क्या बताना है। ओके, no one will go. Okay, so here 1 mole of ideal gas. How much ideal gas is given? 1 mole of ideal gas. Gamma value is also given. Pressure is P1 and temperature is T1. Heated at constant pressure. Pressure is constant till the volume is double. V2 value is going to be 2 times of V1, right? So number 1 mole of ideal gas. So N value is given as 1 mole. 1 mole, gamma value is 1.4, P1, T1, V2 is equal to 2 times of V1. This is also given. And T2 is equal to P1, constant pressure. Then it is allowed to expand reversible adiabatic. Reversible adiabatic till the temperature reduced to T1. Till the temperature reduced to T1. Temperature is already in T1, na? 1 mole of an ideal gas 1.4 at the total, okay, 1 mole of ideal gas at pressure P1 and temperature T1 heated at constant pressure. Okay, first we are heating at constant volume. Acha, okay, then we are expanding. Okay, fine. So basically, yeah, here you can say 1 to 2 is constant pressure, constant. Okay, I'll draw the diagram itself. Right? PV diagram I'm going to draw. So the first process is given that it is a constant pressure heating. Constant. This is, let's say this is 1 point, constant pressure heating. Then isothermal. Then allowed to expand reversible adiabatic. This is reversible adiabatic. So this value is PV to the power gamma is equal to constant. Now in such a way that T3 is equal to T1. T3 is equal to T1, my dear student friends. T3, the total work done you need to calculate. What is the total work done? So to find out total work done, please listen here carefully, right? So W is equal to what, beta? W total is equal to W1 to 2 plus W2 to 3. W1 to 2 plus W2 to 3. Now what is W1 to 2? W1 to 2 value you will get a see. Please listen here carefully. This is very good question, I would say. This is very good question. Why? Because here some people will confuse. They will think that, sir, final temperature is T1, so this point should be here. No, right? There will be an isothermal line like this, right? Isothermal line will be like this, right? Exist. You are getting my point or not, right? So basically here only 2 processes are there. 3-point temperature and 1-point temperature is same, correct? Now in this case W1 to 2 value will come P, or we can say P1 also, you can say P1 I can say, right? V2 minus V1, P1 V2 minus V1. This is basically what? This is basically work done during 1 to 2 process, correct? Then plus P2 V2 minus P3 V3 divided by gamma minus 1. Any problem here? No problem at all. Please listen here carefully. Now answer is given in terms of temperature, so better to convert all these things in form of temperature. Okay, now here P1 is equal to P2 is equal to P, right? P1 is equal to P2 is equal to P, so you can write this like N R bar T. P2 V2, here you can write like this, P2 V2, here you can write like this, P2 V2. So P2 V2 value will come how much? Okay, I will write here P2 V2. Now you may ask, sir, why you are writing P2 V2? I am writing P2 V2 because P1 is equal to P2 is equal to P, correct? So P2 V2 minus P1 V1, here I am writing this P as a P2, here I am writing as a P1, plus P2 V2 minus P3 V3 divided by gamma minus 1. Gamma minus 1. Now put the value. So this value will come how much? This value P2 V2 is equal to MR T2 or NR bar T, right? NR bar T2 minus NR bar T1, right? Plus NR bar T2 minus NR bar T3. T3 is equal to T1 basically, right? T3 is equal to T1, gamma 1.4 minus. Yes. Just solve this one. Just solve this one. N value is given as a 1 mole. 1 mole, even if you put value or fine, otherwise you NR bar you can take common here. NR bar you can take common here, right? NR bar you can take common here, and this can be written as, so here you will get a T2 minus T1 plus T2 minus T1 by gamma minus 1. Even R bar by gamma minus 1 if you take out now, so that will be actually better, right? Because we have to write in terms of CP and CV na. So this can be written as 1.4 minus 1 means 0.4. Even it will be better. Alright, Chandan sir is on the floor. It will be better. You can, if you want, you can put gamma minus 1 as it is, so that R bar by, right, R bar by M into gamma minus 1 is converted to CV. Or n value you can write as a M by capital M. So as per your requirement you can put, no problem. Tell me what is the final answer. Yes, correct. A final volume is pressure until the volume, oh sorry, here V2 value is given 2 times of V1, sorry. V2 value can be written as 2 times of V1, 2 times of V1. So no need to write like this. V2 value is given as 2 times of T1, right? V2 value is given as 2 times of T1. So this value will come P into V1. P into V1 only we can write, or separately you can calculate. So P into V1, or this can be written as, I will write again. So this is 2 times of V1. So this value, this term value will come how much? This term value will come P2 into V1, P1 into V, P into V1, P into V1. or P can be written as P1 is equal to P2 is equal to P. So P1 you can write it. And in next step you can write like a P1 V1 is equal to N R bar T. N R bar T. And this value also can be written like, now V2 and V3 value. Now V2 value is 2 times of V1. V2 value is 2 times of V1. This here also if you require you can write or you can write MR temperature term also you can mention, no problem. Here you can write 2 times of V1 also as per the requirement. You with the help of first law also you can solve correct TPM. That can be written as, because dq is equal to du, that is also correct. There is one another option. There is one another, if this is seems like lengthy, then w is equal to sorry, wait, I will write here w1 to 2. Easy way I am telling you. First you calculate w1 to 2. So that value will come P V2 minus V1, because some people may confuse there. So 2 times of V1 minus V1. So here it will come P into V1 or P1 V1. That can be written as RT1, no problem. Now when you calculate 2 to 3, so you have one option that you can apply first law, right? You can apply here first law. First law is equal to dq 2 to 3 is equal to du 2 to 3 plus dw 2 to 3. Correct? Now what is dw 2 to 3? dw 2 to 3, dw 2 to 3 value will come, this value is going to be 0, right? This value is going to be minus du 2 to 3. Now du is equal to mcv dt, right? Or if this cv, you can write ncv dt also, ncv bar basically, but here actually cv is itself mentioned as a cv bar, right? ncv bar mcv dt, dt value is t3 minus t2 minus t3. Now t3 value is given as a t1, right? t2 value is given as a t3 value is given as a t1. Only you have to replace the t2 value. Only you have to replace the value of t2. How you will replace? For process 1 to 2. For process 1 to 2. For process 1 to 2. Pressure is constant. Pressure is constant. So T2 by T1 is equal to V2 by V1. So this is 2 times of V1 by V1. So this will be cancelled out. So T2 value will come 2 times of T1 also. So this can be written as 2 times of T1. 2 times of T1. So this value will come how much? CV bar T1. CV bar T1 bar T1. In our notation bar is there, right? Now we need to calculate total W. So W1 to 2 plus W2 to 3. This will be quite easy. Even you can put with the formula, and then formula you can convert in form of T. Then R can be written as R. CV can be written as CP minus CV can be written as R. In that way also we can solve, no problem. R bar T1 plus CV T1, right? Is it correct? Check once. P2 V2 minus V3 V3. Okay. So this value will come R bar plus CV into T1. Sir, R bar into CP? Some plus minus mistake is there somewhere? Is there any problem of plus or minus something? Is there? Area of parallelogram you need to know. For area of the trapezium that we used. You tell me here some minus plus problem is there. So Cp minus Cv. Okay. So we know that here I can write Cp minus Cv bar is R bar. So Cp bar is equal to R bar plus Cv bar. So this can be written as Cp bar into T1. Actually, this is written Cp bar only, right? Because yesterday also I clarify that whatever notation we are using, that does not mean that IIT people is also using the same notation. IIT people is also using the same notation. There is no guarantee on that. There is no guarantee. So don't be confused here. See, Cp bar we are using generally when the values are given per mole. When the values are given per mole, then we are using bar. When the values are when the values are given per mole, then we are using Cp, right? Oh, sorry, bar. When values are given per unit mass, then we are using direct C or whatever it may be. Okay. Next question. Everyone's try to solve this problem. Yes. This is molar form of Cv, correct? This is not a cycle problem. FM ka doubt better to ask in FM session. There will be one session on FM also. So I think 13, 12 or 13, one session is there. Either you can ask in that particular session or you can ask in group. अरे करो भाई. Okay, 𝐂𝐤𝐧𝐤𝐬 नहीं किया. So 𝐂𝐤𝐧𝐤𝐬 you can do with the help of crash course if possible. That topic you can do with a crash course if possible. Okay, now listen here. The power developed by turbine in a certain steam plant, the power developed W dot, net power developed. So W net dot value is given as a 1200 kilowatt. 1200 kilowatt. The heat supplied to the boiler, Q input, Q in but per kg. Q in per kg is 3360 kilojoule per kg. Okay. And the heat rejected to the cooling water, Q rejected value is how much? That is 2520 kilojoule per kg. The power developed by the turbine in the certain steam power plant is given as a 1200 kilowatt. The heat supplied to the boiler, is 3360 the heat rejected in the cooling water, that is 2520. The pump work required, pump work, right, W pump work required power is 6 kilowatt. So the steam flow through the cycle in mass flow rate you need to calculate. M dot mass flow rate you need to calculate. Solve fast. Very good, TPM. Which option is correct? Which option is correct? Array, it is a very simple first law problem, bhaiya. It is a first law problem only. It is a first law problem only, beta. The power develop. Okay, oh, sorry. This turbine power. This is WT dot. WT dot value is here. Now, so it is basically operating on a cycle. This is basically operating on a cycle. So for a cycle, basically, for a cycle, we can write here sigma Q is equal to sigma W. Right? Sigma Q is equal to sigma W. Now, heat is added, right? So we can write here Q in dot, everything I am writing in rate, in form of rate. Q in dot minus QR dot is equal to WT dot minus W pump dot. Now these values are given kilojoule per kg. So you can write here M dot into M dot will take outside. So this value will come Q in minus QR is equal to WT value is 1200 minus WP value how much? 6. So M dot value you can calculate Q in. Q in value is how much? 3360 minus QR value is 2520 is equal to 1200 minus 6. M dot value you can calculate how much? How much you are getting? B. 1.42 kg per second. 1.42 kg per second. 1.42 kg per second, right? So shall we move to the next problem? We have 1.42. Okay. Okay, solve this problem. This is a very good problem, and even we have did in the class also. If you recall, we have already solved this problem in the class also. Solve fast. Come fast, solve fast. Come fast, solve fast. Come first, solve first. Very good, TPM. Very good. So here ln v and similar kind of question we have already solved in the class also. We have to draw we want to find out a slope. We want to find out a slope in a curve where x-axis is what? X-axis is t, ln t, and y-axis is right. So this is basically y beta. This is basically y-axis, right? And this is basically x-axis, ln t, right? And we have to find out for adiabatic curve. Now, for adiabatic curve, what is the equation? For adiabatic curve, what is the equation, beta? For adiabatic, for reversible adiabatic. For reversible adiabatic, PV to the power, or use T and V relation. Yesterday I gave 3 relation, if you recall. Yesterday I have given 3 relations. So TV to the power gamma minus 1 is equal to constant. Right? TV to the power gamma minus 1 is equal to constant. Now take log both the side. Right? Take log both the side. Right? So here you will get a ln TV to the power gamma minus 1 is equal to ln P constant. Right? Now here A into B. ln A into B is ln A plus B. So ln T plus ln V to the power gamma minus 1 is equal to ln C. Now this can be written as log property, you already know. So gamma minus 1 will come this side. ln V is equal to ln C. Basically, we want to write in terms of y is equal to mx plus c. So y means ln V I want in this side only. ln V I want this side. So I can write gamma minus 1 ln C. Gamma minus 1 ln V is equal to minus ln T plus ln C. Right? Now what I am going to do, gamma minus 1 I am going to divide here. So ln V is equal to minus 1 by gamma minus 1 ln T. Then it will become some other constant. Let's say C. Right? ln C by gamma minus 1 is also a constant. Right? ln C by gamma minus 1 is another constant. That's it. Very simple. So this is C only. Now this can be written as ln V is equal to 1 by 1 minus gamma ln T plus C. I already told you this is basically represented as Y. This is represented as X. So it is Y is equal to compare with Y is equal to mx plus c. So m value will come how much? 1 by 1 minus gamma. 1 by 1 minus gamma. This is a slope. Solve. Solve fast, Babu. Fast. Solve fast, Babu. Fast. Very good, Adarsh Singh, Rosni, Vishal, Vibhu, Mukul Srivastav, Mac. Very good. All the superstars are here. Shall we move on to the next problem? Okay, let's move to the next problem. Okay, everyone please solve this problem here. Now here it is given that water is boiled at 1 atmospheric pressure. 1 atmosphere in a stainless steel pan with electric range, right? Means electric heater kind of, right? It is observed that 2 kg of liquid evaporates. Please listen to try to understand. When they are saying that evaporation means only the heat required in the evaporation, that only you need to consider. Correct? In 30 minutes, the rate of heat transfer, right? Okay. Please try to understand how much amount of heat is required. how much amount of heat is required to evaporate 2 kg of liquid. How much amount of, right, 2 kg of liquid. So to Q required is basically, right, Q required is basically M into L. This is a total heat required. The total heat required. Total heat required is M into L. Like if you want to evaporate 2 kg of water, then M into L. Now L value yesterday I gave you 2256. Yesterday I gave you 2256, my dear. See, you need not to remember all the values of this latent heat. Latent heat values vary with respect to pressure as well as temperature. Correct, very good TPM, right? So here we can write 2256 approximately. This is a latent heat at 1 atmospheric pressure. This is a latent heat at 1 atmospheric pressure, right? Okay, so this value will come how much? 2256 into 2. So this value will come 4512 kilojoule per kg. Kilojoule, sorry, kilojoule, not kilojoule, kilojoule. Now, but actually we are not interested in Q. We are interested in Q dot. We are interested in Q dot. So Q dot value will come how much? Q dot value will come Q by time, my dear student friends. So this value will come 4512 divided by time. Time is 30 minutes. 30 into 60. We are writing in seconds. So this is divided by 30 divided by 60. So this value will come 2.51 kilowatt. Very simple problem. Very simple but highly conceptual. Right? Very simple and highly conceptual. Very simple and highly conceptual problems. Very good. Shall we move on to the next problem? Shall we move on to the next problem? Sure. Okay. Solve this problem. Everyone try to solve this problem. See, here given that a Carnot engine having efficiency is 0.5. Carnot engine have and it is driving a refrigerator which has COP of 5. So it is like we have one heat engine that is taking Q1 amount of heat engine and rejecting Q2 amount of heat at lower temperature. Then whatever work it is producing, that work is going in a refrigerator. That refrigerator, let's say, taking heat from lower temperature, that is Q3, and rejecting Q4 to the higher temperature. This kind of system is there. Now here two conditions are basically given. So in such type of problem, I have already told you, right? In such type of problem, I have already told you, you have to write all Q in terms of Q1. You have to write all Q in terms of Q1. Basically what they are asking that the ratio of the heat rejected to the ambient to the energy absorbed by, okay. So ambient, how much heat? See, this is also ambient, this is also ambient. Let's say this is taking heat at let's say a T1 temperature, but it is rejecting at atmospheric temperature, TATM, right? Ambient only, right? So it is rejecting. Here it is taking heat from the place where we have to cool, but this also we are rejecting the T naught. T naught I will write here, T naught. This also I will write T naught. T naught. So basically what we need to find out, Q4 plus Q2 by Q1. This basically we need to find out. The ambient energy absorbed by the energy. Okay. Clear hai? So how we will proceed? I told you earlier also, in such type of problems, only you have to focus on how we can convert all Q in terms of Q1. For example, the efficiency given 0.5, that is 1 minus Q2 by Q1. 1 minus Q2 by Q1. So Q2 value will get a 0.5 Q1. Q2 value will get a 0.5 Q1. Q2 value you are going to get a 0.5 Q1. This Q2 value. Now come to the another case, that is COP is also given, right? Now what is the COP of a refrigerator? COP of a refrigerator is given as a 5. That is nothing but equals to Q3 by Q4 minus Q3. Now one more thing I would like to share here, that Q4 minus Q3 can be written as Q1 minus Q2, because same work. Whatever work is produced by the engine, same work is going to be consumed by the refrigerator. Whatever work is produced by the engine, the same work is going to consumed by the refrigerator. Okay. So this is Q1 minus Q2. So now I can write here, my dear student friends, 5 is equal to Q3 by Q1 minus Q2. So Q1 is Q1, Q2 is 0.5 Q1. So this value will come 0.5 Q1, 0.5. So Q3 value will come 0.5 Q1, 0.5, 2.5 Q1. Now we have to find out Q4 value. So Q1 minus Q2 is equal to Q4 minus Q3. So what is Q1? Q1 is Q1 minus 0.5 Q1 is equal to Q4 plus minus 2.5 Q1. So Q4 value will come how much? This is 0.5 and this 2.5 will have 3 Q1. Now what we have to find out? We have to find out Q4 plus Q2 by Q1. Now what is Q4? 3 Q1 plus 0.5 Q1 divided by Q1. This value will come 3.5. This is answer. These are very, very good problems. These are very, very good problems. See, in this session, you can see that these questions are very, very good, right? There are very good chances that these type of questions may ask in the exam, right? So Super 20 series is going on. We are solving the problems. So everyone come fast and we'll continue. Very good, very good, very good. Next problem. Solve next problem. Similar kind of problem you will, because engine is driving the refrigerator. What you are asking? Sir, why you are taking same work in engine and refrigerator? Yes, because Vibhu, yes, TPM is giving the correct answer. Because the engine is going to drive the refrigerator, na? So whatever work will be produced by the engine, that is consumed by the refrigerator. Very simple. The second law efficiency. What is second law efficiency? The second law efficiency is basically actual efficiency by reversible efficiency, right? And this is actual. Now this is given as 0.6, that is equals to actual efficiency is given as 0.36. Now what is reversible efficiency? 1 minus TL by TH. So you can write 1 minus TL by TH. TL by TH value is how much? TL value is given as 310. This value you can write here 310 Kelvin. So what is the value of TH? So TH value you need to find out TH value. solve fast. So I can write like 0.36 divided by 0.6. This is 1 minus TL by TH. This will go this side, this will go this side. So 1 minus 2 by 5. TL by TH value is 2 by 5. So 310 divided by 775. Yes. 775 Kelvin. 775 Kelvin. Very good. 775 Kelvin. Very good. Okay. Everyone solve this problem also. Everyone solve this problem. Vibhu. Vibhu, come fast. Now, in this problem, if you see a house that is losing heat at the rate of 54,000 when outside temperature drop to 4 degrees centigrade. It is heated by electric resistance heater if the house is maintained at 25 degree temperature all the time. Right? Okay, the second law efficiency you need to find out. Very good. See, first you try to find out, in this particular case, first you try to find out how much reversible work input is required. See, suppose you have one house, right? This is your house. This is your house TPM, and it is maintained as 25 degrees centigrade, but outside temperature is 4 degree. That's why it is rejecting heat by the rate of 54,000 kilojoule per hour, or we can write like 54,000. Okay, write in kilojoule only, no problem. Kilojoule per hour only, no problem. So if you want to maintain this room, if you want to maintain this house at the same temperature, the same amount of heat you need to supply. Same amount of heat you need to supply to maintain this temperature. Otherwise, you will not able to maintain. If you supply less amount of heat, then the temperature will drop. If you supply more amount of heat, then temperature will increase. If you want to maintain same temperature, then exactly same amount of heat you need to supply. Assume that I am supplying this with a heat pump. Sir, why you are considering heat pump? Because I want to calculate W reversible. I want to calculate W reversible. Very good. So, so this is taking heat from 4 degrees centigrade and W reversible work. Just assume that you have a reversible heat pump and you are using like this, right? So what is COP of this heat pump? COP of this heat pump is equal to TH by TH minus TL, right? TH means 273 plus 25 means 298 divided by 298 minus 4. 277. So COP of heat pump is equal to QH by 54,000 by W reversible. From here I can calculate W reversible value. So W reversible value will come how much? So COP value will come 14 point something. So 54,000 divided by answer. So this value will come 3805.37 kilojoule per hour. This much reversible work is actually required. This much reversible work is actually required. But please listen here. Please listen here. This is a reversible work that is required. correct? This is a reversible work that is required. Okay, now but actually how much would, but actually we are not using this one. Please try to understand. This is hypothetically I am calculating the W reversible, so that's why I consider here heat pump. Actually I am not using heat pump. Actually what I am using, actually I am using one for, this is let's say home, and here I am using electric resistance heater. So this is W actual, and temperature is maintained at 25 degree temperature, and heat is rejected as a 54,000 kilojoule per hour. So sigma q is equal to sigma w, like or dq is equal to du plus dw. Du value will be 0. dq is equal to du plus dw. Du value will be 0. Why du value will be 0? Because temperature is maintained constant. So W actual value will come 54,000 kilojoule per hour. So actually you need to supply this much amount of heat, whereas reversibly you can supply this much amount of heat. So what is the correct answer? Right. Now we have to find out the second law efficiency. So what is second law efficiency? That is W reversible by W actual. So this value will come 3805.37 divided by 54,000, right? So this value will come divided by 54,000. So this value will come 0.0705, right? Or you can say 7.05%. These are really a good problem. So W actual one more time. Okay. Now please try to understand W actual one more time. Okay, no problem. So here basically what we have, air is there. So in this case I can apply first law. Apply here first law. So first law value will come how much? dq is equal to du plus dw. Now du value will be 0 because temperature is constant. And 25 degree temperature is maintained, na? 25 degree. So here we are maintaining 25 degree temperature. That's why du value will become 0. dq value is how much? Minus 54,000. Rejecting, na? W value is how much? Minus W actual. So W actual value will come 54,000 kilojoule per hour. Is it clear? Who is asking this question? Raju Mahanto. Raju Mahanto, is it clear? Raju Mahanto, is it clear? Actually, I am not able to see the comment. Comment I am able to answer, I am able to see, but name I cannot able. I am not able to see in the TV because TV is little bit far away. I have to zoom it somehow. सर हाँ सेम आएगा क्योंकि COP सर कैलकुलेट इफ कॉर्नर. Yes, correct. आगे. Okay, let's come to the next problem. Wow. A metal block of 25 kg Metal block 20 by 300 Kelvin immersed in infinite large liquid means the temperature of liquid is not going to change. It is treated as a reservoir. The system compares the block and N2 are attained thermal equilibrium. The average specific heat of metal block is then the entropy generated. Very easy. Entropy generated. Yesterday I have explained very well that entropy generated. Pandit ji is always right. Yes, Pandit ji is always right. Sir, we use direct Carnot question and came same efficiency. Carnot if you use, yeah, then also it will come same. But the point is, it is a heat pump, so you can use Carnot. Same thing we did, bhai. Carnot efficiency, how can you use? Because it is a problem of refrigerator, na? Yes. So yes, they are asking entropy generated during the process. So entropy generated, entropy of the universe, entropy, like all these words are basically same only. Net entropy change, yesterday I have discussed. Yesterday I have already discussed that all these words are same. Everyone please solve fast. Everyone please solve fast. तुम जो कह दो तो चांद तारों को तोड़ लाएंगे हम Okay, now delta S generation you calculate or delta S of universe, both are same thing. So assume that block is our system. So what is ds of metal block? What is ds of the block? That is mcln T final by T initial. Correct. T final by T, mcln T final by T initial, mcln T final by T initial. So what is the m value? Basically m value is given as 25 kg into C value is 0.45 ln T final. Final temperature is how much? Final temperature of the block will be 77 Kelvin. Initial temperature is 300 Kelvin. So this value you will get, that is ds of system, I can say. ds of system is ds of block. So 77 divided by 300 ln of answer into 0.45 into 25. So this value is minus 15.2993, I can write it. 299 actually, 15.3 unit will come how much? Kilojoule per Kelvin. Now you need to check how much this is the entropy change of block. Now you need to check how much amount of heat is going to be rejected by the block. So Q block is equal to mc dt, right? Magnitude only I am calculating here, or right, the m value is 25 into 0.45 300 minus 77. I am calculating the heat rejected by the block. The heat rejected by the block. So how much heat is rejected by the block? 300 minus 77 into 25 into 0.45. So this value will come 2508.75 kilojoule per Kelvin. Yes, kilojoule per Kelvin. Kilojoule per Kelvin. Okay. No, sorry, kilojoule. Now we'll calculate ds of nitrogen bath. So now whatever heat is rejected by the block, whatever heat is rejected by the metal block, that is going to absorb by the nitrogen bath. So basically its value will come Q by T. So Q value is come how much? 2508.75 divided by temperature value is how much? 77. Correct. Q by D plus. Now so this value will come to divided by 77. So this value will come in plus, that is 32.581168 kilojoule per Kelvin. Now we have to calculate delta S generation. Delta S generation is nothing but a ds of universe. I can write means ds of block plus ds of nitrogen. So this value will come minus 15.3 plus 32.58. So 17.28. Yes, correct. Solve it fast. Solve it fast. Chacha, fast. Babu, fast. Ashish Gupta, fast. Venkat, fast, beta. Aman Kumar, very good. Shall we move to the next problem? Okay. Now here we have a next problem with you. Now this is the next problem. Now 1 kg of air at pressure P1 and temperature 900 Kelvin mixed with 1 kg of air at same pressure but 500 Kelvin. Determine the loss of availability. Gauss-Todala theorem. T naught into ds of universe. सर लिक्विड N2 टेम्परेचर क्यों नहीं होगा? क्योंकि हीट गेन कर रहा है N2. So see, when I'm calculating here, see, when I'm calculating ds of N2 bath, then I'm taking N2 temperature only. N2 temperature. Whatever your system is there, that's like, if you want to calculate the entropy change of block, then you have to take entropy change of block with final temperature of the block is equals to bath temperature, and initial is 300 Kelvin. Here temperature is constant. अच्छा, क्यों चेंज नहीं हुआ? Okay. See, here it is infinitely large. You listen here. Okay. Now I got it. You are thinking that change क्यों नहीं हुआ? Because it is infinitely large. तन्मय बारी, तन्मय चंद्रकांत बारी, it is infinitely large. बट N2 टेम्परेचर इंक्रीज होगा ना. अरे तन्मय चंद्रकांत बारी, हे भगवान, इस तन्मय तुम मेरे घर आओ थोड़ा बेटा, तुमसे बात करनी है. तुमको मारे पहले तो. Array, very good. So now listen here. So here I am going to assume that this mixing is going to take place adiabatically. No heat is going out, right? So I am assuming that there is no any heat is going outside. So ds of surrounding value will become 0, right? So remaining ds of system is ds of air we have to find out. Now what is the ds of air, right? M into Cp ln T2 by T1 minus R ln P2 by P1, right? Okay. Now here you need to understand one more thing. The same gas is going to be mixed, right? Same gas is going to be mixed, and the very important point, the air is like initially one air is there, like 900 Kelvin air, that is also at P1 pressure. 500 Kelvin air, that is also at same pressure. So if you mix na, then also mixture pressure will also be same. Mixture pressure will also be same, correct na? Mixture pressure will also be same. Now what I am considering here, please try to understand. I am considering here or you can do one thing, first final temperature also you need to find out first. Do one thing, first you calculate, find out the mixing first. So energy balance you apply, energy balance, heat lost by hot body, even same whether you have, okay, hot body, hot air is equal to heat gain by cooled air. Now this air I am considering as a 1, this air I am considering as a 1, this air I am considering as a 2, correct? Now, so directly should I write? T final value will come, T1 plus T average will come, okay, I will write here. So mass mc of air, whatever mc of air, and dt, T heat lost means T1 minus T final is equal to heat gain by m. Same m is there, same c is there, both have 1 kg, same air is there. So T final minus T2. So T final value will come T1 plus T2 by 2. So this value will come 900 plus 500, 900 plus 500 divided by 2, that is 700. Now ds of air I am writing like this, ds of air I am writing like ds of first air plus ds of second air. First air formula will come m, right, Cp ln T final by T1 minus R ln P final by P1 plus m into Cp ln T final by T2 minus R ln P final by P2. Now here P1 is equal to P2 is equal to P final is equal to P1. Same matlab, all are same. So if all are same, here pressure variation, so this value will become 0, this value will also become 0, because only mixing is going to be take place. M value is 1 kg only, Cp will take outside. So M value is 1 kg, Cp value also consider 1 only or 1.005, whatever you want, 0.005 ln, right? T final is how much? T final is 700, 700 by 900 mcln T final by T initial plus ln T final by so what is the value basically? So 700 by 900 ln of answer plus ln 700 divided by so this value will go into 1.005. So this value will come 0.08558 kilojoule per Kelvin. Now ds of universe value will come how much? ds of universe value will come ds of air plus ds of surrounding. This value will become 0. So ds of air value will come both the complete air after mixing 0.0085583 something like. Now we have to find out irreversibility. Irreversibility is equal to T naught into ds of universe. ds of universe. T naught value is given as 300. So this value is 300 into 0.08588 to 300. So this value will come 25.67 kilojoule. Very good. That also you can do. Loss is equal to available energy, that also you can do, no problem. Whatever available energy change will be there, that also can be considered as a loss only. So that also you can consider, but actually I did like this so that a uniformity will be there, right? By that equation you cannot always solve. Answer you will get same. Answer you will get same TPM, but generally I always recommend the students to, whenever loss they are asking, then always use Gauss-Todala theorem. It will be little bit lengthy, I understand this, but at the same time you have clarity, you will not get confused. Okay, next problem. Right, next problem. Everyone solve this problem. The mass flow rate of air in a compressor. Very good. This is also easy problem only. No sir, just mentioning value. Yes. The mass flow rate of air in a compressor is 1 kg per second. The condition of inlet is 0.1 megapascal, 300 Kelvin. Initial temperature is 300 Kelvin. The pressure at the exit is 0.1 megapascal only. Means pressure is not increasing. Pressure not increasing. The condition at the inlet is okay. The pressure at the exit of the compressor is same only. Oh. Okay. Assuming the compression process is adiabatic and reversible and the air is to be ideal gas, the power input required in kilowatt. Is there any problem in this question? Because pressure is not changing. I also feel there is some typing error, I think so. I think there is some typing error. Let me check once. Let me check I have shared the question. I think there is some typing error. Wait. I'm checking. Yes, Tanmay Chandrakant. Wait. I'm checking. I don't have this question with me. Okay, solve another problem. I think there is some mistake. It may be 1 megapascal, yes. You try to solve with 1 megapascal. You try to solve with 1 megapascal. I think this is not there. You try to solve by 1 megapascal and check whether the answer is matching or not. Try to solve with 1 megapascal. Try to solve with 1 megapascal and tell me whether the answer is matching or not. Because I am not able to find the question. Right, just take 1 megapascal here. I think by mistake they have written here 1 megapascal. You just take 1 megapascal and then find. Okay, so now I am also solving along with you. Let's see, it is a reversible adiabatic. It is a reversible adiabatic. If it is reversible adiabatic, T2 by T1 is equal to P2 by P1 to the power gamma minus 1 by gamma. Okay, so T2 value we need to find out. P1 value is 300 Kelvin, P2 value is 1 megapascal, P1 value is 0.1 megapascal. Gamma value, the air is there, so 1.4 minus 1 by 1.4. From here you will get T2 value in Kelvin. T2 value you will get in Kelvin, right? T2 value you will get in Kelvin. Right, T2 value will get in Kelvin. So this value will come 0.4 divided by 1.4. Okay. And 10 to the power answer into 300. So this value will come 579.21. That is basically T2 value, right? T2 value is known to us, right? T2 value is known to us. Now W value we need to find out. So what is the formula? SFE, steady flow energy equation. So m dot into H1, kinetic potential energy we are going to neglect because nothing is mentioned, plus Q dot is equal to m dot into H2 plus W control volume dot, right? Now this value we are taking 0 because it is adiabatic one, and for the adiabatic reversible and the air is ideal gas, power input to the compressor, right? So power input, so this value is going to be negative. So I can take is this side, so W compressor dot is equal to m dot into H2 minus H1, H2 minus H1. So H2 minus H1 can be written as Cp dt. So Cp T2 minus T1, Cp T2 minus T1. M dot value is given, yes, 1 kg per second. So the 1 into 0.005 into T2 value is 579.21 minus 300. So this value will come how much? Minus 300 into 1.005. This value 280. Wow. 280 points, approximately 280 kilowatt. So I think we were correct. We guessed that it is 1 megapascal and it was correct. Right, it was correct. Shall we proceed to the next problem? Now Cp value of air you have to remember. Cp value of air you have to remember 1.005 Cp and Cv value 0.718 and R value is 0.287. If you don't remember, then I gave one formula also. Cp is equal to gamma R bar by m into gamma minus 1. Gamma R bar by m into gamma. Can we apply PV in open system? PV in open system, no. PdV you are asking. PdV if you are asking, no. VdP we can apply. Yes, Vibhu. पूरा एकदम ठंडा हो गया है मामला, हीटर जल रहा है उसके बावजूद. A heat engine receive heat from a source 1200 Kelvin at the rate of 500 kilowatt and reject waste heat at medium of 300 Kelvin. The power output is given. So reversible power, first we have to go see. Efficiency or reversible efficiency is going to be 1 minus TL by TH. That is equals to W reversible by Q input. So 1 minus TL, TL value is 300 by TH value is 1200 is equal to W reversible value is 500 kilowatt divided by Q input. Sorry, W reversible we need to calculate. W reversible by 500. So from here you will get W reversible value how much? Right, so 1 minus 300 by 1200. So W reversible value will come 375 kilowatt. So this is going to be the answer. But the actual efficiency is given as a, actual work is given as a, this is reversible work, that is 180 kilowatt. So they are asking the irreversibility. Irreversibility is W reversible minus W actual. So 375 minus 180 if you do, you will get 195 kilowatt. So D is going to be your correct answer. D is going to be your correct answer. For adiabatic, can we apply? That you can apply. See, you can apply either open system or closed system only for air, for given air. Either mass flow rate must be constant, right, or mass will be constant. So you can apply for both, no problem. Adiabatic equation PV to the power gamma can be used for any case, whether it's open, because only consideration is what? Only consider reversible adiabatic and ideal gas. How many people are there? Okay, next question. Solve next problem. Everyone solve this problem. 8 kg of helium undergoes a process from the initial state 3 meter cube per second, right? 3 meter cube per kg, sorry. So initial volume is given, 8 kg, mass is given, 15 degrees centigrade is also given. Final state, final volume is given, final temperature is also given. If the surrounding is to be this one and this one, then what is okay, useful, very good. Solve. V is equal to constant, can we do the same? Like adiabatic, if process is same, then for that ideal gas equation will be same. To try to understand, see whether it is an open system or closed system, ideal gas equation is going to be the same, and PV to the power gamma is equal to constant is the ideal gas equation for reversible adiabatic process. Okay. गेट एग्जाम क्लोज सिस्टम है कि ओपन सिस्टम? गेट एग्जाम कोई सिस्टम नहीं है बाबू. Solve fast. So here, how to solve this? 8 kg of helium undergoes a process from an initial state of 3 meter cube per kg. So initial volume V1 is given and temperature T1 is given. Final state P2 is given V2 is given and T2 is also given. If the surrounding is T0 is also given, P0 is also given, increase in useful amount of potential of helium during this process. So what is the change in the available energy? Useful amount of available energy. So you can use, there can be multiple things, but as it is fixed mass is given 8 kg. Fixed mass is given, so you can use here U1 minus U2 minus T0 S1 minus S2, and as it is a useful work, so minus P0 V2 minus V1. Gate is an isolated system. Yes, yesterday I told you, right? Gate is an isolated system. Right? First you have to isolate yourself. Eh? Chandan sir is asking the question. Dashing Chandan sir. एक तो हमको ये टीवी में दिखता नहीं है कमेंट. Everyone solve it fast. हेलो क्लास में आशीष गुप्ता डी. Please solve it fast. हेलो Everyone please solve. Just wait for 2 minutes. 2 minutes I'm coming. 2 minutes I'm coming. What is the answer? Okay, आशीष गुप्ता डी ये नहीं समझ. Okay, नहीं समझ में आ रहा. So you are okay. Now please listen here. So here 8 kg helium is given, right? 8 kg helium is given. Initial conditions are given. So please try to understand that we have to increase in useful work. So W useful work, right? W useful you need to find out. That is basically phi1 minus phi2, if you recall. Phi1 minus phi2. Yesterday also I gave you phi1 minus phi2. So this phi1 minus phi2 can be written as u1 minus u2 minus t naught s1 minus s2 minus p naught v2 minus v1. Very simple. So now initially, now this can be written for ideal gas. What you can write? This is mCv dt. So m will take outside Cv T1 minus T2, right? mCv dt minus T naught. Now helium is a gas. So for that, what is the change in entropy? S1 minus, not S2 minus S1 minus S2. So this value will come Cp ln T1 by T2 minus R ln P1 by P2. or actually we can use pressure is given, final pressure is not given. Okay. Final pressure is not given. So better to use another formula, V wala formula, right? So here you can write CV ln T1 by T2 minus R plus R ln V1 by V2 minus P naught into, this is given per kg, na, this is per kg, so M into V2 minus V1. Now just put the values. Just put the values, you will get the answer. Just put the values. Arey, this is the useful work I told you yesterday also, bhai. This is the useful work I told you yesterday also. So this value will come 8 into helium. What is the CV value of helium? Is it given? No, not given. Right, CV value of helium, right? So if you recall, shall I write in another slide? Properties of helium. What is? Oh, Siri connect हो गया. अरे Siri मैं तुमको नहीं बोल रहा जेस to find the value of. Okay. So what I'm trying to say, CV value. Okay. So R of helium is 8.314 divided by 4. So 2.08 kilojoule per kg Kelvin. Now CV value is equal to R bar by M into gamma minus 1, right? So this value will come R bar 8.314 divided by 4 divided by 0.67. So this value will come 3.102 kilojoule per kg Kelvin. If CP required somewhere, I don't know. 5.18. कौन है आज परेशान कर? Right. Now put the value here. So 8 into CV value is how much? CV value is 3.102. So 3.102 into T1. T1 value is how much given? 15 degrees centigrade. 15, or we write in Kelvin actually, because anyhow we have to convert 15. So 288 minus 80. 353. Actually, it is increasing now. So 5.2 minus 5.1 we need to calculate, by the way. It is better to calculate 5.2 minus 5.1, because if you calculate 5.2 minus 5.1 na, right, then it will directly come increased value. Here I am calculating 5.1 minus 5.2. So we are basically try to calculating decrease the amount of labor, useful work that we are getting, or decrease actually I am calculating. So this value may come negative, but final answer you have to write in that only, right? Minus T naught. T naught value is 273 plus 25. 298 into 3.102 ln 288 by 353 plus 2.08 ln V1 value is how much? 3 by 0.5 Acha, here also m will be multiplied, don't forget this. Here is also m is going to be multiplied in this also m here also it will multiply, so 8 here also 8 will be there, minus p naught value is 100 into 8 into v2 0.5 minus 3.1023. Now you just solve this. So this value will come final answer I am writing. I think how much coming? 68 TPM, you tell me. So I think it will come approximately, if you calculate 69840 approximately increase in useful work. This is basically increase in useful work. Please calculate and tell me whether you got this answer or not. Please calculate and tell me whether you got this answer or not. Please calculate and tell me whether you got this answer or not. Please calculate and tell me whether you got this answer or not. Everyone, please calculate, because if this type of question will come, it is going to take too much time. It may take little bit more time. So be ready for the fast calculations. D aayega sir. Yes, very good. Good afternoon. Very good afternoon, Mr. Rudra. Sir, V2 value is 0.5 कैसे लिया? See, this is given na. This is the final state. Final state, final temperature. See, always remember, like if you are considering that, sir, what about surround? It is a surrounding one. So, the जितना सिस्टम एक्सपैंड करेगा सराउंडिंग उतना ही कंप्रेस करेगा, राइट? You are getting my point, right? So even though it is a surrounding work, right? But in surrounding work also you need to consider system volume change only. Why? Because the amount of system increases its volume, the same volume is going to be decreased by the surrounding. Okay. Am I clear here? Shall I move? Is it clear, everyone? Okay, please calculate. You will get this A as answer. A as answer you will get. Okay. Okay, this question you solve. Now here it is given that 1 kg of mass iron at 1200 Kelvin allowed to cool 400 Kelvin, environment is at 300 Kelvin. The specific heat is 0.5. So first you see irreversibility is very easy. Irreversibility is T0 into ds of universe. That's it. So ds of universe is ds of block first. So ds of iron is how much? That is MC ln T final by T initial, right? So M value is how much? M value is 1 kg into C value 0.5 ln T final. T final value is 400 by 1200. 400 by 1200. Right? Then this value will come how much, bete? 400 by 1200 ln of this answer into 0.5. So this is 0.05 0.0493 kilojoule per Kelvin. Kilojoule per, this is ds of iron, right? Now calculate ds of first calculate dq of iron. Q of iron means amount of heat rejected by the iron. Amount of heat rejected by the iron. Rejected magnitude I am calculating. The amount of heat rejected by the iron, that is mc T1 minus T2. Why I am writing T1 minus T2? Because amount rejected I am calculating 1 into 0.5 into 1200 minus 400. So this value will come 1200 minus 400, 800 into 400. This value will come 400 kilojoule. So this much amount of heat is going to the surrounding. So what is ds of surrounding? ds of surrounding will come Q by T naught. Q naught, right? Q value is 400 by 300. So this value will come 400 by 300. 1.3333, right? So ds of universe value will, this value is came positive, negative. This value is negative, I hope so, right? This value will come negative, na? This value is negative, na? Right? This value I think negative. Let me cross check one more time, bhai. 400 divided by 1200 ln of this answer into 0.5. अरे यार ये गलत लिख दिया मैंने. Minus 0.549. Okay. So ds of surrounding. So ds of universe value will come how much? ds of universe value will come this plus 1.333. So this value will come 0.7837 kilojoule per Kelvin. We have to find out irreversibility. Irreversibility is T naught into ds of universe is into 300. 235. A is going to be correct answer. A is going to be correct answer. A is going to be correct answer. Very good. Are you done with this? Done, completed. Done, completed. Shall we move to the next problem? Sir, anyone started studying in the December basics of only academic, what would you suggest? But condition is he is repairing it. Please explain. So I'll suggest you only consider 4 subjects. If someone is not studied well up to now, so only 4 subjects I will recommend you. First one is math, right? Another one is maths, then aptitude, and any 2 technical subject, whatever your most favorite subject. And just try to clear the gate. Just try to get a 30-40 marks, right? And then prepare for next year. Okay, solve this. The specific volume of steam after expansion in the turbine is, after expansion the specific volume means it is V2 basically, V2. Right, the specific volume of steam after expansion in the turbine V2 at this pressure and the saturated liquid and vapor specific volume. At this pressure, the saturated liquid and vapor. Okay, so saturated vapor specific volume. So VF value is given as 0.001 meter cube per kg and VG value is 15.25 meter cube per kg. What is the dryness fraction? See, it is very simple. So the whatever final volume is there, right? Whatever the final volume is there, or we can write V only, no problem, because V1 is not given, na? So it is one state problem only. So V is equal to, we can write VF plus X times of VG minus VF. Now this value is given as how much? 12. This value is given as 12 is equal to VF. VF value is 0.001 plus X times of VG, that is 15.25 minus 0.001. So calculate X value from here. I hope so, right? This only they are asking. Even you can calculate approximately also, you will get the same. 12 minus 0.001 divided by this value will come 0.7868 like that. A is going to be correct. Done? Are you done? Pravalika, are you done? Okay, let's solve the next problem. Oh wow, beautiful problem. Little bit seems like lengthy but beautiful. Right, solve this problem. Everyone solve this problem. Here it is given that a mass of wet steam at a temperature of 165 . A mass of wet steam at temperature 165 degrees centigrade is expand at constant quality. So actually quality is not going to change. Means X is equal to constant 0.8 to the 3 bar. So it is coming to the 3 bar. Okay. Find the enthalpy change during the expansion process. Very easy. So T1 value is how much? T1 value is 165 and T2 value will be given. T2 value will be saturation pressure at 3 bar. 3 bar means 300 kilopascal. So 133.52. So two states are known. Now calculate H1 value. H2 value, and then enthalpy change H2 minus H1. That's it. Very simple problem. It is something like this. Like if I draw the diagram here, if I draw the diagram here, let's say this is a vapor dome. So one point is basically, right, these are the two pressure lines. Let's say one point is somewhere here, right? Then it is following the same curve like this. Is 2 points, same x value, okay? So first calculate H1 value. H1 is equal to, right, 1 point. 1 point data is which one? 165. So this is 1 point data, 165 degrees centigrade. This is 1 point data, this is 2 point data. These data are waste, not required. These data is not, only try to confuse you. So H1 value will come HF 165. So 697.24 plus 0.8 times of 24 plus 0.8 times of Hg minus Hf 2762.8 minus 697.24. Then calculate H2 value. H2 value, how much you will get? H2 value you will get 561.43 plus 0.8 times of 2724.9 minus 561.43. Calculate H2 minus H1. What is the answer? Right. So here I am using H1 is equal to, this is one data. This is data for 1. So H1 is equal to HF plus X times of Hg minus HF. And this is 2 data, 2 point data. These 2 data are waste, only try to confuse you. Okay, A answer is coming up. Okay, so this value will come minus 57 point, how much? 57. We check. So A is going to be your correct answer. A is going to be your correct answer. Okay, solve this particular problem. Everyone. A saturated liquid at 1500 kilopascal, 500 Kelvin. This is a saturated liquid is there at this particular condition. With the enthalpy value, means HF value is the given. HF value is throttled to the liquid vapor at this pressure. This is a final pressure, final temperature. Okay, throttling process is going to take place. So actually H1 is equal to what? H1 is equal to HF at 1500 kilopascal and 500 Kelvin. So this value will be 750 kilojoule per kg Kelvin. This is given, the H1 value. Now this is going to be throttle and enthalpy of saturated liquid. This is HF value at this condition. This is the enthalpy of saturated vapor. Okay, this one. Original liquid which is vaporized. Now do one thing. So for throttling process, throttling, H1 is equal to basically H2. So H1 is equal to 750 and H2 is equal to HF plus X times of Hg minus HF. Now problem is solved. Now these values you have to take at 150 and 300 Kelvin. These values are at 150 kilopascal and 300 Kelvin. 300 Kelvin. 300 Kelvin. So just put the values. Just put the values. Here you will get 750 is equal to HF. HF value is how much, beta? HF value is how much? 500. No. Yeah, 500. 500 plus X times of 2500 hello. Right. So here 2500 minus this one, right? So X value you can calculate. Solve it fast. Solve it fast, beta. Right, is very easy, bhai. Throttling process is there. This line is very much about throttling. See, now if I draw here, let's say HS diagram. Let's say I'm going to draw here HS diagram, right? So complete HS diagram I'm going to draw. So it is something like this HS diagram, right? So initially it is given that initially the mixture is at 1500 kilopascal. So let's say I'm going to draw here. This is 1500 kilopascal line. 1500 kilopascal. Okay. And initially it is somewhere here. The first point is somewhere here at one point. Saturated liquid line. This is saturated liquid line. This is saturated vapor line. Right? Now then we are throttling it to the 150 kilopascal. 150 kilopascal. So now what I am going to do? Throttling means this is a throttling process. Right? Okay. Actually, okay. This 2 point can be anywhere actually. Okay. So this is 2 point, for example. So here H1 is equal to H2. I put here H1 is equal to H2, right? So when I put H1 is equal to H2 Pravalika, so 750 minus 500, 250 divided by this one. So this value will come 0.125, right? What is this? This is nothing but the mass of vapor to the total mass. X is the mass, so this is only they are asking. So if you write this in percentage, then it will be 12.5%. They are asking how much, what is the mass of vapor that is converting, mass of vapor to compress. So here when throttling is going to take place, here we have liquid. After throttling, liquid plus vapor is there. So they are asking how much percentage of liquid is going to convert into vapor. How much percentage of liquid is going to convert into vapor? So that is 12.5. Clear hai? Okay. Next question. Choose the correct answer. Joule-Kelvin coefficient is 0 for ideal gas. Yes, 100% correct hai. In Joule-Kelvin expansion, cooling achieved when initial temperature must be below the, yes. initial temperature must be below the maximum inversion temperature, right? That I explained, right? So if I draw the diagram, TP diagram, right? So then it will come something like this. This is a maximum inversion curve. If your temperature is somewhere here, so it will always go heating only. It will always heating only. So if you want cooling, then the actual temperature must be less than maximum inversion temperature. So this is also correct. So 1 and 2 both are correct. A is correct answer here. So this we all have already discussed. 2 nahi, 1 or 2 both are correct. Sorry. Joule-Thomson को okay. Now, according to Maxwell, which of the following are correct? Very easy. So you just which are correct? So you just draw here. Right. So Shivam sir, very talented person. Now, first this one, right? So start with V. So VTP, right? VTP. These are the mass of VTP is equal to minus SPT, correct? So this is basically correct. This statement is correct. This statement is correct basically, right? Okay, this come. So here dou S by dou V, dou S by dou V, SVT minus, then PTV minus. So minus, this is also correct. PTV minus, so S, okay, this is also, so all are correct basically. These are all are 4 equation I have given to you. 4 equation I have given to you. Then Maxwell's relation. So as per the Maxwell, all 4 equations are going to be correct. All 4 equations are going to be correct. Clear? Last problem. I think last problem only, na? Yes. Last problem, solve. Solve the last problem. Solve the last problem. So here we have to use Clapeyron equation. B and C same. B and C same. Eh? Oh yeah, B and C is same. Okay. B and C same. Okay. Then also all of above is only correct. Then also all of above is only correct. Now Clapeyron equation, we have already seen that the latent heat means Hg minus Hf by T saturation is equal to dP by dt saturation Vg minus Vf. So with the help of this formula you can solve. Sir, heating replace the cooling, then what will happen? Then no problem. If the actual temperature or initial temperature is above the maximum inversion temperature, then right. Sir, sign कैसे check करना? Sign you forget. Okay, sign. I told you, if curve is go like this downward, then this is negative curve, right? Minus you have to take. If the curve is like this, then we have to take positive. For example, if I take this one, so VTP, so VTP will come like this and SPT will come like this. So this is downward, this is upward. So this value will be positive. So dou V by dou T at constant pressure, that is positive, and dou S by Dou S by dou P at constant temperature is going to be negative. So one I wrote, similarly you can write other one also. Solve this. Everyone solve this. So what they are asking? dP by dt. So now if you calculate dP by dt saturation is equal to, now what is Hg? The saturation temperature 40 degrees centigrade and 6 bar liquid, the specific volume and specific enthalpy. Specific volume, specific enthalpy is 75. The specific volume is dry saturated. So this value is 200. So 200 minus 75, 200 by 75 divided by T saturation. What is T saturation? 40 degrees centigrade. So 273 plus 40. So what is, where is the calculator? So 273 plus 40. So this value will come 313 into Vg. Vg value is how much? Vg value is dry saturated 0.02 minus 0.0008. This only, na? So 200 this value will come 20.8. 20.8, right? Kilopascal per Kelvin. So D is going to be correct answer. D is going. Now everyone please listen here carefully. So here we solved 20 behtareen problems, right? We solved 20 behtareen problems where we can where we consider classes Clapeyron one. There are number of problems based on properties of pure substance. There are number of problem on first law also. Like almost every type of problem is covered, right? Not every, but 60-70% concepts are going to be over, right? Now in next class is, right, I'm writing here the next class is at 7 p.m. 7 p.m. ME channel. ME channel, right? So in ME channel 7 p.m. one session will be there, so you have to attend that session, because further we are going to solve approximately 30 more problems. 30 more problems we are going to solve, and believe or not, those problems are going to be very, very useful for you. I'm telling you, those problems are going to be very, very useful for you. Okay, so let's meet in next session at 7 p.m. Thank you. Let's meet in. So don't forget to come. I will share the link in the Telegram channel. Okay, let's meet.